Welcome back to Summarize Science. Have you ever wondered how computers in video games or movies can understand what a person is doing just by looking at their skeleton? This technology is called skeleton-based action recognition, and it usually requires a ton of data that has been manually labeled by humans, which is a very slow and expensive process. This paper introduces a brilliant solution using a concept called active learning. Instead of passively learning from a huge, random pile of data, this AI actively seeks out the most valuable examples to learn from. Think of it like a smart student who, instead of reading the whole textbook, asks the teacher for the specific problems that will help them learn the fastest. The core of this method is a new acquisition function that doesn't just pick examples, it actually designs the perfect ones to learn from. This process balances three key ideas: representativeness, diversity, and uncertainty. First, it wants examples that are typical of what it might see in the real world. Second, it looks for examples that are very different from what it has already been trained on to broaden its knowledge. And third, it specifically requests examples that the AI is currently most confused about, directly targeting its weaknesses. To make this possible, the researchers developed a special kind of network that is bidirectional and stable. This basically means it can translate the complex skeleton data into a simpler, more abstract language, design the perfect learning example in that simple language, and then translate it back into a skeleton for a human to label. The stable part is crucial, as it ensures this translation process is reliable and doesn't create nonsensical skeletons. So, does it actually work? The results are impressive. Here on the SVU dataset, you can see their method, especially the latent version which does the designing in that simpler space, achieves vastly higher accuracy than other methods when using the same tiny amount of data. For example, with only 15% of the data labeled, their model achieves over 75% accuracy, while others lag far behind. They saw the same pattern on a second, more challenging dataset called FPCHE. Again, at low labeling rates like 30% or 15%, their method consistently outperforms random selection and other common strategies. This proves the system is incredibly efficient at learning, squeezing the most value out of every single labeled example. So let's recap the main takeaways from this incredible research. The researchers created a far more efficient way to train AI for action recognition by using active learning. Their system intelligently designs a small but powerful set of training examples by balancing how representative, diverse, and uncertain they are. This is all powered by a special, stable GCN that can move between the complex real world and a simpler latent space. What this means for the future is that we could develop powerful AI for things like robotics, smart surveillance, and advanced human-computer interfaces much faster and cheaper. It lowers the barrier to entry by removing the need for massive, expensive data labeling projects. By teaching AI to ask smarter questions, we can help it learn more with less. Thanks for watching Summarize Science.